To do percent yield problems, you need to know that percent yield is the actual yield divided by theoretical times 100. The actual yield is what you make in the lab. The theoretical yield is the answer to the stoichiometry problem. It's what you theoretically should make if everything goes well. So it's like a test. If you were supposed to get an 80, but you actually got a 60, 60 is your actual. You were supposed to get 80. So your percent yield is 75%. 60 divided by 80 times 100. To solve a problem like number 1, if your actual yield is 20 grams and you were supposed to make 60, so 60 grams is the answer to the problem, 20 divided by 60 times 100 is 33%. And since there's only one sig fig in these answers, I'd say 30%. If your percent yield is 75% and your theoretical yield was 80, how much product did you actually make? So again, 75% is the actual over the theoretical times 100. Sorry about this. So 75% of 80, basically. 75% equals actual divided by 80 times 100. If you divide both sides by 100, you get 0.75 equals actual times 80. Multiply both sides by 80 equals your actual. So 75% of 80 is your actual yield. Your actual yield is 60 grams. Now let's do one with the stoichiometry problem. Calculate the theoretical yield of potassium chloride produced when 45 grams of K2CO3 react with excess HCl. So to do this, you need a balanced equation. The balanced equation is, there's two K's on the left, so I need two potassiums on the right. Now I have two chlorides on the right, so I need two hydrogens on the left. I have two hydrogens on the right and one carbonate on the left and the right. So the balanced equation is 1, 2, 2, 1. I'm starting with 45.8 grams of K2CO3. I need to go to KCl. So I'm going to go grams of K2CO3 to moles of K2CO3 because stoichiometry must be done in moles. Then I can go to moles of potassium chloride. Then I can go to grams of potassium chloride by multiplying by the molar mass. So the first step is going from grams to moles. Given 45 grams of potassium carbonate, if each mole weighs 138 grams, I have under a mole, I have a third of a mole. 45.8 divided by 138 is 0.33 moles of potassium carbonate. And apparently I did not pay attention to significant figures. Once I know the moles of potassium carbonate, I can multiply by the mole ratio found in the balanced equation. I'm going to potassium chloride. There are 2 potassium chlorides formed for every potassium carbonate. Since moles of potassium carbonate is on top, I'll put it on bottom, is given. That way they cancel out. 2 moles of potassium chloride are formed from every mole of potassium carbonate. So I'm basically doubling it. 1 potassium carbonate makes 2 potassium chlorides. So 0.3 potassium carbonates make 0.6 potassium chlorides. Finally, my last step is to go to grams of potassium chloride. So I need to multiply 0.66 by the molar mass. 1 potassium and 1 chloride add up to 74.55 grams per mole. Doing the math, I get 49.4 grams potassium chloride. That is my theoretical yield. So, if I want to calculate percent yield, and only 46.3 grams of potassium chloride are produced, I need to use the formula. Percent yield is actual over theoretical times 100. I was supposed to make 49 grams. I only made 46. My actual yield is 46. 46 divided by 49 times 100 is a 94% yield. Try to do the back side of the worksheet.